Module Technical Course IoT for Industry 4.0. Lecture 2, IoT Systems Prototyping based on online engineering tools. During this lecture, we will discuss the possibilities of online virtual and remote engineering tools for studying and prototyping Internet of Things technologies and systems. The application of modern prototyping technologies helps to save time and money, as it allows to identify unwanted errors and optimize the parameters and characteristics of IoT systems at an early stage of project implementation. Today, prototyping is the name of several related technologies that can be used effectively in the design of IoT systems. They are prototyping embedded devices, prototyping the physical design, prototyping online components. Methods of prototyping of information systems include the following types: rapid, evolutionary, incremental, and extremal. Rapid prototyping allows creating a prototype that is not part of the finished system, but is used for research at the stage of agreeing the final requirements for a system being designed and its functional and design characteristics. Evolutionary prototyping or breadboard prototyping is the consistent creation of layouts gradually approaching the real finished system. These types of prototyping are also useful for the developing IoT systems. Online engineering is a generic definition for a wide range of related technologies: remote and virtual laboratories, online simulators, cloud technologies, etc. Online engineering technologies can be successfully used for prototyping IoT systems by sharing engineering equipment, specialized software, as well as cloud platforms and IoT services. Universities around the world have developed and continue to create a huge number of online laboratories. Today, the most popular are remote laboratories in the field of control engineering, robotics, and electronics. You can see more detailed information about existing resources using this link. The diversity of the remote and virtual laboratories for different areas of study makes it difficult to find and select necessary tools for usage in design process. The number of possible options increases, but the time to make a decision is usually limited. To select a laboratory, it is necessary to take into account a set of criteria. So, in this case, the task of multiple criteria analysis is implemented. To structure and classify the criteria, the hierarchy diagram was created. A fragment of the main criteria is presented on this slide. They are category, subject domain, availability, language, and reusable components. Additional criteria are the equipment used. It can be standard, for example, Arduino, Raspberry Pi, or original. The method of experiment control, and others. There are several projects that provide information about remote and virtual labs and make it easy to find the right one. They offer an extensive database of laboratories and a large number of filters for working with information. Firstly, it is the Go Lab ecosystem, which allows to select remote and virtual laboratories according to learning objectives based on an extensive database and provided filters. The goal of the Labs Land project is also to organize the information and help in selecting the appropriate online laboratory. An important advantage of this service is useful information about open source and proprietary development tools provided by WebLab Deusto developers. The open source remote laboratory management system is proposed to create common layers of online laboratories. It provides several ways to easily and quickly develop your own remote and virtual laboratory. Let's start analyzing virtual labs and environments that can be used for prototyping IoT systems. Simuli Virtual Lab is designed to support the creation, verification, and continuous monitoring of IoT systems. This platform allows creating realistic models of IoT devices based on various components and parameters that can be configured to simulate the interaction of devices with the environment and dynamically control this process through the application programming interface. Similar Virtual Lab provides an interactive workspace for electronic prototyping of IoT systems based on Arduino, STM32, and Raspberry Pi microcontroller platforms, as well as various peripherals. WalkWe is an online virtual laboratory for simulating electronics. The goal of the project is to provide a convenient and powerful tool for programming based on the Arduino and other platforms and creating prototypes of electronic devices. WalkWe offers many ready-made examples of the implemented devices, measuring instruments, and allows to simulate the operation of various devices, in particular LED emitting diodes, shift registers, sensors, 7-segment display, a keyboard, etc. Tinkercad from Autodesk is a free, powerful, and easy-to-use web platform for 3D design, electronics, and coding, trusted by over 50 million people around the world. The main possibilities of Tinkercad are visual editor for schemes and program codes, collection of models of most popular electronic components grouped by type, debug and circuit simulation modes, ready-to-deploy Arduino project with schematic and code, the ability to export the resulting sketches and electrical circuits into real projects, integration with the rest of Tinkercad functionality, the ability of fast creation of 3D models of structural elements of the device being developed, for example, a case, built-in manuals, and a huge community with a collection of ready-made projects. The previous slides presented virtual instrumentation for prototyping IoT systems. However, working with real hardware is very important for developers. Therefore, we will discuss the next group of online technologies. Modern remote laboratories are online engineering tools that provide access to remotely controlled devices and installations, as well as to the study of various control and design technologies, effects, laws in different areas. Thus, they provide the efficient organization of the joint usage of various engineering equipment, taking into account financial and economic constraints. For instance, such remote laboratories as WebLab de Gusto, Rele, can be successfully used not only by students, but also by engineers for prototyping the created IoT systems based on reusable solutions. One of the well-known projects is Goldie, Grid of Online Lab Devices, which offers a network of laboratories with real equipment around the world. The Goldie hardware and software were developed by the Integrated Communication System Group at the University of Technology, Germany. Goldie is an example of hybrid laboratory that provide two different options for running an experiment on real equipment or on a virtual model. The wide range of experiments, real and virtual, can be performed based on various combinations of control units and physical systems. A virtual model is an application that simulates a real experiment and allows multiple users to work at the same time. That gives more possibilities and eliminates the problem of a limited number of users that can simultaneously work with the equipment, as well as the probable loss of stream from a webcam in case of technical problems. The next object of our consideration is integrated complex IoT, which contains real equipment and a virtual model. Therefore, it can be classified as a hybrid remote laboratory. It includes two interconnected parts: a remote laboratory for development of embedded systems and Smart House and IoT Laboratory. This complex can be effectively used for the practical study of IoT technologies based on real equipment, such as hardware-software platforms, sensors, and actuators. The first part of the integrated complex is remote laboratory for design of embedded systems. The architecture of remote laboratory is typical as for other remote laboratories. Main components of the system are Arduino board, sensors, actuators, web camera, and laboratory server. 4 remote experiments in the field of object control are available for developers. They are LED emitted diode, servo, display, and ultrasonic sensor. The laboratory provides users with streaming video to view the current status of experiments and process control results, as well as interface with various scenarios for performing remote experiments. Descriptions of remote experiments, several scenarios for each experiment, the results of parameters measurement, and their visualization are presented on web pages. Based on provided information about so-called software solutions and components, students and developers can create their own projects and observe the progress of experiments. The second part of the integrated complex is remote laboratory, smart house, and IoT. The set of equipment looks like a prototype of a real smart house system. The proposed remote experiments correspond to typical home automation subsystems and control tasks. They are solar station, lighting control, climate control, access control, safety control, zone control, presence control, ventilation, illumination control. Working with experiments allows students and developers to study the logic of the smart house system functioning, programming, and processes monitoring. Our remote laboratory, smart house, and IoT can be used to study the energy efficiency, safety, and cybersecurity of smart house systems. To study the issues of resource saving and energy efficiency, various experiments are possible to control the parameters of lighting, heating, air conditioning, ventilation, and recuperation systems, as well as solar energy production. To study safety and security issues, several experiments were implemented to monitor access to controlled areas and facilities. Cybersecurity is one of the remote laboratories experiments that offers opportunities to study wireless, cloud, and mobile technologies, as well as IoT services usage. The developed interactive virtual model for the remote laboratory, smart house, and IoT allows obtaining useful information about the components of smart house system and simulate the control processes. User can interact with the virtual model and access data from model components. This helps them to create their own home automation solutions based on the rewarding experience of working with our virtual model. Online information space offers a huge number of electronic components and boards. Nevertheless, the time for their selection is usually limited. The designer should be guided in all this variety, in vast amount of information on websites and their descriptions. The application of recommendation systems will allow to obtain information about ready hardware software platforms and components for selection and making decision on the IoT systems realization. Texas Instruments service is an example of a recommended system for electronic component selection. It provides filtering of schemes and elements of the company in accordance with the input parameters, searching for compatible products of the company, etc. Another well-known electronics manufacturer, STM microcontrollers, based on the selected debugging platform, offers a list of possible compatible platforms within its products, as well as related materials. Microchip offers the parametric search tool to search for ATML and microchip microcontrollers and microprocessors based on user-entered parameters. So, the remote and virtual laboratories and environments can be effectively used as online tools for the IoT systems prototyping and reusable solutions investigation. Online engineering tools provide students and developers with the necessary knowledge and skills for implementation of their IoT projects, as well as for the successful application of IoT technologies in the professional activities. The existing recommendation systems simplify and speed up the search for components for the development of IoT systems, as well as facilitate the selection of online tools for their prototyping. On this slide, you can see the list of recommended sources of information. Thank you for your attention.